Welcome back, everyone. Example 2 is going to be very similar to example 1. Again, I'm going to show you how to identify these key features, not only using your graphing calculator, but also using the nifty website, www.desmos.com. Okay, so example 2, we're graphing the parabola y equals negative x squared plus 3x plus 6. Okay, so I'm going to kind of walk you through both methods. Again, after example 2 and example 3, you can kind of decide, well, I prefer using my graphing calculator or I prefer using desmos.com, and you can kind of use the method that you prefer to use. Okay, so let's pull up my calculator and also, wrong calculator. This calculator will not help me graph. And I'm also going to pull up desmos.com and kind of show you again simultaneously how to do this. Okay, so I'm going to go back to the y equals. The way that you clear out your equation is by hitting the clear button. Okay, so our next equation is y equals negative x squared. Now be careful, you guys. The only time you use this negative key down here is if your leading coefficient is negative. If you have any other negatives in your equation, you have to use the subtraction symbol. So just be careful. So it's negative x squared. And then, oh, did not put my x. Jeez, Miss Long. Okay, so x squared, there we go. Okay, and then plus 3x, so plus 3x. And then plus 6. And again on Desmos, you just type it in. You click on one of these boxes and you type y equals negative x squared. Again, hit shift 6 to get that exponent, or hit the keyboard button and hit the squared or this button to get to the exponent. All right, and then plus 3x and then plus 6. Okay, so I'm going to hide my keyboard. Okay, so again, I'm going to show you at the same time. You can either hit the graph button. I just will let you know if your parabola is not in a 10 by 10 screen. I usually just go ahead and do zoom 6 to get it to a 10 by 10 window screen. There we go. Okay, so the first thing is we want to know what are the x-intercepts for the graph, which the x-intercepts is where the graph crosses through the x-axis, or where it smacks the x-axis. Okay, which if you see this time, you guys, it hits the x-axis. Look at that. Okay, so again, you can find your zeros. Again, your button on your calculator that you need to go to is the second trace button. That's where you're going to find everything. Now, when you're trying to find x-intercepts or zeros, you need to go to the 0 button, which is either by clicking number 2 or by arrowing down and hitting enter when you get to number 2. Now, since we have 2 places where the graph hits the x-axis, we're going to have to do this 2 times. Okay, so again, left bound, we want to go to the left of the 0, which to the left of the 0 would be underneath the x-axis. So I'm going to get my little spider guy and scroll over till I go underneath the x-axis. If you guys see now, I'm slightly to the left of the 0, so I hit enter. Where I go to the right of the 0 is above the x-axis. So if you see now, I'm slightly to the right of the 0. I hit enter, and then when I ask for guess, you hit enter again. Okay, so one of my zeros is at the point negative 1.3722. I'm just going to round it. I'm going to go ahead and write that on my paper before I forget. So one of my x-intercepts is where x equals, let's see here, negative 1.37, I'll say. Or that is the point negative 1.37 comma 0. Okay, and then I have to do the same thing to find the other 0. So I have to click second trace 0. So click 2 or scroll down and hit enter when you get there. Okay, so now I need to get my spider guy closer to the other 0. Okay, so this time to go to the left of the 0, if I want to go to the left of the 0, this time to the left of the 0 is going to be above the x-axis, which my spider guy is already there, so I'm already good. So I hit enter, and then go to the right of the 0. I need to scroll underneath my x-axis, hit enter, and enter. And there we go. Our other 0 is at the point x equals, I'll say 4.37. 4.37, or that is also the point 4.37 comma 0. Okay, so that's how you find zeros on your calculator. On Desmos, again, after you type it in, it already highlights your zeros. So you can like hover over it or just click. So I can just go ahead and click on my zeros and bam, I already know my zeros. So there you go. My two zeros are at the points negative 1.37 comma 0 and 4.3720. So again, Desmos, you just click. You don't have to do all the scrolling and hitting enter. So in my opinion, it's easier. Okay, so I've just filled in my zeros right now. Again, you can label them on your graph. So my two zeros are here. So these are my x-intercepts. Okay. All right, next thing, y-intercept. Let's go. Okay, so again, I need to go to my second trace button. Where you go to find your y-intercept, that's when we go to the value button. And we want to know what y is when x is 0, because when x is 0, that means you're on the y-axis. So when x is 0, your y-intercept is at 6. So I can say that my y-intercept is where y equals 6, or the point 0, 6. Okay, and then again on Desmos, it's really easy. You just simply click. I know my y-intercept, I know my zeros. Look at that. So it's at the point 0, 6. So there we go. Our y-intercept is at the point 0, 6. Now looking here, let me label my picture. Oh no, I like to color code things. Jeez, Miss Long. Sorry, I'm going to do this in green just because I want it to be prettier. There we go. It's important for math to be pretty, right? Okay, so my y-intercept is right here on my graph. So this is my y-intercept. Okay, the next thing, I need to determine if my parabola has a maximum or minimum, which I already know that since the a value is a -1 secretly, it's a negative a value, which means it's less than 0. And negative graphs are the sad graphs, which means they have a maximum. So I already know it's going to have a maximum. So at my minimum, I'm going to say none. So I don't have one. All right, well, let's find our maximum point. Let's go back. Okay, so again, to find your maximum, again, your key button is second trace. That's your best friend right now. All right, so I'm going to go down to maximum, which is 4. So I'm just going to click 4, or you can scroll down and hit enter. It's up to you. Okay, so I need to go to the left of my maximum. So when you go to the left of the maximum, you're going to hit enter. Then you need to go to the right of the maximum. So I'm going to get my spider guy over. Hit enter. And then when it says guess, hit enter. So my maximum is at the point 1.58.25. So let's see here. It's at 1.5 and then 8.25. So sorry, I'm writing it on my paper. I'll show it to you in a little bit. Okay, and again on Desmos, you just click. Click. Got my zeros, got my y-intercept, got my maximum. So there you go. Okay, so here we have found our x-intercepts, our y-intercepts, and our maximum. Okay, and also guys, don't forget, I completely forgot in example 1, don't forget to name your graphs. Your graphs deserve a name. Okay, they deserve a name. Okay, so I named my first graph Sarah and my second graph Catherine. So make sure you guys name the graphs. They deserve a name. Whoa, and I just dropped my mouse. Okay, but anyways, so now we need to find the end behavior, which I'm going to show it to you on this picture. Again, normally you would have to look on a graph to get this information on a calculator, but I think it'll just be easier to show it to you on here. So remember, end behavior, this is where you ask yourself, well, where do your arrows point on the left side of the graph and the right side of the graph? Okay, so as x is approaching negative infinity, it's headed in a negative direction, which means it's headed to the left, which I might not be able to, okay, here we go. Okay, so on the left side of your graph, where's your arrow pointing, you guys? Is it pointing up or down? What do we think? So I'll get my arrows drawn. Well, it is pointing down. Okay, so as x approaches negative infinity, which means on the left side of your graph, f of x is headed down. So we're headed down. So if we're headed down, is that in a positive or negative y direction? When you go down, are your numbers getting more positive or more negative? Well, they're getting more negative. So this would be as f of x or y is approaching negative infinity. So if you are headed down, the answer will be negative infinity. Okay, then as x approaches positive infinity, or on the right side of your graph, so this is down, on the right side of the graph, you need to ask yourself, where is the arrow pointing? Is it pointing up or down? Well, on the right side of the graph, it is pointing down. So if we're heading down, again, that is a negative direction, which means f of x will be heading toward negative infinity. Sorry, my infinities are getting crooked. But anyways, don't forget, you guys, you will always ask yourself, what is the graph doing as x approaches negative infinity and positive infinity? Or on the left and right-hand side of the graph, where does your arrow point? Which, since we have a parabola, the arrows either both point up or both point down. So they'll either both be negative infinity, or like in example 1, they'll both be positive infinity. So just keep that in mind. Okay, now for our intervals of increase and decrease. So if you're looking at your graph, okay, remember you start by tracing from left to right. It's like when you read a book, left to right. Okay, so when you trace, that will determine if you go up, it's an increase, and if you go down, it's a decrease. And the point where it's kind of changing from an increase to a decrease is where your maximum or minimum point will be. And that point is also called a turning point because it's where the graph changes directions. Okay, so again, this was your maximum point. I completely forgot to label it. Jeez, Miss Long. So this is your maximum. So this is kind of the dividing line. So I'm going to go ahead and draw in this dividing line. It's where your axis of symmetry is. Because if we're to the left of this line, these are the x values that are less than whatever the x value is here, which is 1.5. Okay, if we are to the right of this line, these numbers are larger than 1.5. 5 is larger than 1.5. So these are the x's that are larger than 1.5. Okay, so both of these are going to involve 1.5 in some way. We just need to determine if they will be greater or less than this value. Okay, so your intervals of increase or decrease, you're basically going to look at the x value in your minimum or maximum point and decide, are the x's larger than that value or smaller? Okay, which I'm going to show you how to do that again on Desmos, because I think it's kind of fun to do it on Desmos. So my dividing line, so that was at 1.5, so that'll be the vertical line that hits it at 1.5. So that's my dividing line. Okay, so if I trace from left to right, I will be going upward. So am I increasing or decreasing on the left? I am decreasing. Sorry, good golly. I am heading upward, which means I'm increasing. Sorry, guys. So the x's on this side, are these numbers larger or smaller than 1.5? Well, -4 is smaller than it. So if you type x is less than 1.5, if you guys see, it shades in the side of the graph that only has the increasing part. Okay, so if you're kind of trying to decide, like, I don't know which inequality to put, you can just test it. Like if I would have put greater than, oh, come on, Sloan. If I were to put greater than, it is not shading in the side of the graph that I'm looking at. Okay, so when I'm increasing on the left, I need to make sure this is shaded in, which I get that by typing in a less than. Okay, it also makes sense because the x values that make the graph increase are to the left of my maximum, and the numbers that are to the left of 1.5 in the maximum, these numbers are smaller than 1.5, so it's where x is less than 1.5. Okay, so if you're ever on the left of your maximum or minimum point, it's always going to be a less than. And if you're on the right, it's always going to be a greater than. And depending on the way the graph faces will determine if it'll be increasing or decreasing on the left or right. Okay, so the graph is increasing on the left, so the increasing interval is where x is less than 1.5. So I'm going to write that on my paper. Okay, so again, this is where the graph is, this side is where the graph is increasing, this right here. Okay, the graph is increasing. All right, so it's increasing where x is, since it's to the left, it's where it's less than 1.5. All right, same is true on the other side. So the other side, it's heading downward, which what does that mean? Is the graph increasing or decreasing? the graph would be decreasing on the right. So these are the x values that map to the graph and make the graph decrease. So since these are to the right, these x's are larger than 1.5. So it would be where x is greater than 1.5. Okay, and again, if you're ever second guessing yourself, you can just kind of guess and check. Like you could go on here. Now I'm looking at where the graph is decreasing. So if I say x is greater than 1.5, it is shading on the side of the graph that is decreasing. So I know I have the correct inequality. Guys, so again, if you aren't quite sure, you can always just type it in on Desmos and see, well, which half of the graph is being shaded in. And that will be the correct inequality. Okay, and lastly, our domain and range. I'll just talk about that on our paper. Okay, so don't forget, you guys, domain are the x values. And you ask yourself, how far left and how far right is the graph going to go? Which, remember, this graph is going to gradually get wider and wider, which means it's going to continually go left and right. Okay, and it's going to hit every single x value, which means my domain is all the x values. All the real numbers will be x. So we're going to use this nifty symbol, x is all real. Okay, and don't forget, when you have a parabola, this is always your domain. Okay, always. Now the range, you ask yourself, how high does the graph go and how low does the graph go? Because the range deals with the y values. So let's see here, how low does the graph go? Well, since I have arrows pointing down for forever, it's headed to negative infinity. It's heading down for forever. And then how high does the graph go? Well, it goes all the way up to the maximum, which the maximum is at 8.25. Okay, so I know it's going to involve an 8.25. I just need to know, are the values on the graph larger or smaller than 8.25? Okay, so are these numbers on the graph down here, are they larger or smaller than the 8.5 up here? Well, they are smaller than that value, which means y is less than or equal to 8.25. And the reason why it's equal to, you guys, is because we have a solid point there. Okay, so your range should always have an equal to symbol. So if you have a maximum, what's going to happen is your range is always going to be less than the maximum because it's headed down. Okay, if you have a minimum, your range is always greater than or equal to the max or the minimum point because all the values, since it's facing up, are headed upward. So minimums, your range is always greater than or equal to. Maximums, your range is always less than or equal to. And I just wanted to say one more comment. So the reason why your intervals of increase or decrease are not equal to, well, the reason for that, I forgot to explain it in example 1. The reason why is because at your maximum or minimum point, the graph is kind of in between. It's kind of changing from an increase to a decrease. Okay, so it can't really equal a maximum or minimum point for an increase or decrease because that is the point where it's changing between the two. Okay, so that's why when we do an interval of increase or decrease, we don't do an equal to symbol. Okay, so it's either always greater than or always less than because at the point where x is 1.5, it is transforming from an increase to a decrease or vice versa. So whenever you have an interval of increase or decrease, it cannot equal the value. When we have a range on a parabola, we'll always have an equal to because we should always have a shaded endpoint. Okay, you guys, well, that's it for this graph. Again, in example 3, if you'd like to try example 3 on your own, you can. And again, on example 3, I want you to kind of start picking which method you prefer to use. You can use both methods. It's always good to check yourself. So sometimes it's good to do both to, check yourself to see if you did it right. But usually, people want to just stick to one method. So example 3, you can try on your own if you want to. And you can also pick the method you would prefer to graph and find these nifty key features. I'm already excited about example 3. Let's get going, you guys.